I know it's still a busy time for you as you prepare for examinations. I'm Gabby Jacobs. I'm one of the publishers here at Future Managers, and I've been focusing mainly on native engineering titles since I've been here. I really appreciate that you're here and that you are invested and you're here to learn more about the syllabus changes for the subject. We know that syllabus revisions, it can be a cause for panic sometimes, and we don't always like change, but we're hoping to put you at ease in this session. Just some gentle housekeeping. I have muted everybody, but we will be monitoring the chat. So I'll keep an eye on that for us. On your screen, let me just go there now. On your screen, you'll just see a session breakdown. So before I introduce our facilitator, I'm just going to go through, just want to show you what we're going to be discussing today. So we'll go through each module in the syllabus one by one, as it corresponds with some of the sample copies you probably have. As I said, we've muted microphones, but we will allow time for you to ask questions once we're done with the module. But you'll see that we've got a Q&A session right at the end. So you'll be able to ask more general questions and get clarity there. Let me just admit some more people, sorry, so that we can all get in here. Okay. Sorry, thank you. Right, and so now on to the person you're actually here for. Piet du Toit has 35 years of experience teaching mechanical engineering subjects in our colleges. He's also walked the talk and has spent time in industry, both locally and abroad. For 8 years, Piet also served as the N6 Strength of Materials and Structures Examiner for the DHET, and he's the author of a number of technical textbooks. Piet and I have worked together since 2020 when our Mechanotechnics syllabi were revised, and in this time it's become very clear how much passion he has for helping students succeed. With that said, I'm very excited to hand over to Mr. Piet du Toit, who will be taking you through this new syllabus. Piet.
Okay, good afternoon, everybody. I hope it's going to be an enjoyable session for you. Starting off, like Gabby said, we're going to go through each module. we tried to put some that we think is important sections on each module just to sort of introduce you to the book, but obviously there's much more, many more things in the book that you will find once you've got the book in front of you. So looking at the modules, I will spend a bit more time on module 6, which is your renewable energy systems, and also module 3 on the steam generation, the last part on the nuclear power plant. So if you can maybe go on to module 1. First of all, that you will find in the syllabus itself, the taxonomy, knowledge and understanding, your percentages that is required in actual exams parts, so it's more for the examiner. Here are the 6 main modules, and the part that was new, obviously that was never in this previous syllabi, is your weighted values. So you can have an idea more or less how much time you should spend on each module. So the modules of the 20 marks, or maybe you could take a week or 2, where the other modules of 10 and 15 should take a week, more or less. So just for you as a lecturer to maybe decide how much time you want to spend on various of these modules. Okay, syllabus changes. The syllabus has not really changed drastically. Goes a little bit more in detail on certain sections, but like I said, the only major changes are the nuclear power plant section, part of the STEAM, and then the completely new module on the renewable energy. So new formula, stuff like that we need to just discuss a bit. I just want to concentrate quickly on module 6, so we will go over that later on. Specifically, at the start of every module in our textbook, you will have the set outcomes from the syllabus, specifying what the student needs to be able to do. So you can see on the renewable energies, there's a lot of new stuff. The only thing that you might recognize there is 1, 3, 4, 5, bullet point number 5. It talks about the Rankine cycle. I think everybody who's taught power machines should know that any steam plant runs on a cycle or ideal Rankine cycle. So the basic principle stays the same. Doesn't really matter if it is a coal-fired plant or if it's a nuclear-fired plant, a nuclear power plant. Okay, remember that future managers always list the syllabus learning outcomes at the start of each module, so that you and your students will always know what the learning outcomes are and what is expected from you. Okay, if we start off with module 1 now, there are no really important changes in the module. I've tried to, in the book, concentrate a bit more on what is the actual PV diagram. So if you look at that left-hand figure, I tried to show them just a general PV diagram, that there are actually 3 main lines, which is all those horizontal lines representing pressures, and the vertical lines, your volume lines, and then your like hyperbola type of shape lines, which is your temperature lines. To first just introduce a student that a graph can follow any of those lines or part of those lines. And then from there we start the introduction to all the processes, your 5 processes, starting with a constant volume, and then a constant pressure, and then a constant temperature. And finally to the adiabatic and polytropic processes, which I'm sure you're all familiar with. Nothing new. I tried to include, what we did with these processes, we included the cylinder at the bottom just to show the student that the gas is working on the piston when you are doing expansion problems, and that the piston is actually working on the gas when you do a compression system. So that we say why is work done sometimes negative and why is work done sometimes positive and so on. So I just tried to make that a bit more clearer to the students. And then just before we do the summary of the actual module, you will find that all 5 processes are set up in the table. All the relevant formulas that you need are there. The ratios are there. Change in internal energy for each one, the work done for each one, the heat flow for each one. So it's like a summary, which obviously would be ideal if we can get that in an exam. Eh? Okay. Do we need to stop here maybe and just see if there's any questions on module 1?
They can just put up their hand.
If it is, maybe if I maybe went over too quickly or anything, is there anything that any questions, like a general question maybe? I know we've got time right at the end to actually ask some questions, but if there's maybe something that's unclear on module 1, if you can raise your hand maybe, Gabby can have a look if we need to address something.
Thumbs up, so I think
Okay, thank you. There's some thumbs up, so we can carry on with module 2. Module 2, very important for me. Also, no changes in module 2. It still states single acting air compressors, or sorry, single stage compressors. And it only specifies without clearance or with clearance. So we've covered both. And I've put this diagram in just again to make sure lecturer and students that you can see that they are actually successive processes, first of all. So it's not just one process. It's like from A to B as a process, and from B to C as a process, and from C to D as a process, and from D to A as a process. So that sort of explains that. Then I've drawn 3 curves for the students that they can see that the ideal cycle is a thermal cycle, which is from B to F, so that you can minimize the work done. But the actual practical cycle is more on the adiabatic version, which gives a bit of a steeper curve due to your exponent being gamma and being 1,4 for air. And if that results in a bigger area under the curve, and that results in a bigger work done or power required. And then we can explain to the students that doing a water spray as one example to try and get the curve to be closer to the isothermal curve. And we finally end up with a polytropic one, which is then more or less the sort of curve that we work with when we do the expansions. We work with the polytropic process. So that is just to indicate to them. And things that's also important is that without clearance, there's basically a V1 and a V2, and that's all really. And that the students can realize that V1 is called your cylinder volume. It's also called your stroke volume. And there's no clearance. And the volume 2 is called your volume after compression. So nothing really involved there. But if we go on to the compressor with clearance, then I show in detail in the book what all these different volumes are, from V1 being cylinder volume, and that we have a V1 and a VE1. Explain the difference between that. We have a V2 and we have a VE2. So all important volumes, because that determines, if you work with V1, you get the total mass in the cylinder. And when you work out VE1, which is the volume that is actually drawn into the cylinder, you get what they call effective mass. So there are some calculations on that. If you go on to subsection 2.1.3, explain, every volume is explained there. What is stroke volume? How is it calculated? How do I calculate cylinder volume? The volume after compression is called V2. The volume after expansion is called V4. And then what the students are very confused sometimes is they don't understand the difference between cylinder volume and volume drawn in once you've got clearance. So I've labeled all these volumes that they can actually see on the diagram, which volume is which volume, and give a relevant formula for each one. Same with volume delivered. There's a difference between V2 and VE2. There's also a difference between mass, effective mass, and mass that remains behind in the actual part of the cylinder that is has a clearance volume, so not all masses are pushed out. So that's all explained in detail in the textbook. So I've just sort of highlighted it for you. Yes, that concludes basically module 2. Like we said, there aren't any new principles really, other than we try to make it, with my experience, I just know that the students usually have a big problem with all the effective volumes and effective masses that is asked and had to be calculated. Again, I can just ask if it's, is it okay if we carry on to the next module? Or is there anything maybe that's unclear in module 2? Looks like it's okay. Thumbs up. Thank you very much. We'll carry on to number 3. Steam generation and nuclear power plants. The first part of this module is dedicated onto the actual steam part of it, starting with very basic stuff on how to use the steam tables, how to get specific enthalpies, if it's water, if it's wet steam, if it's dry steam, if it's superheated steam. I'm sure everybody is familiar with that. It's nothing that has changed. A little bit of a diagram to see what the actual steam plant looks like, more or less, like a line diagram. That is also expected from the students to be able to actually draw in the exam.
Sorry, Piet, we just got a question from.
Okay, sorry, we got a question.
From Mr. Victor Nodem.
Yes, thank you.
From you, sir.
Yeah, thank you. I was little bit when Mr. Dutoit was asking the question. I was trying to get the mic button. I did not know that it was hidden from your side.
Feel free to speak if you want.
Hello? Can you hear me?
Sorry, we can hear you.
Yes.
Okay, I just want to go back on the compressor, if you can allow me, Mr. Dutoit. Is there any difference between the mass of air drawn in to the mass of air delivered?
Sorry, again, is there a difference between mass drawn in and mass delivered?
Yes, please.
No, that's exactly the same thing.
It is the same mass.
Yes, the mass doesn't change. The only thing that is different is both of those masses are called effective mass, and then you get the total mass that's in a cylinder. That depends on the cylinder volume, but the mass that is drawn in and delivered, that is a little bit less, and that depends on the effective VE1 and VE2. I want to go back quickly. I just want to show you something. If you look at these two formulas for volume drawn in with effective 1 and volume drawn in effective 2, the only difference is the one you work with T1, the other one you work with T2, and then P1 and P2. So the two volumes will be different, but the two masses that you calculate, doesn't matter if it's ME, if you want to call it ME1 or ME2, they stay the same. If you use the same formula, MRT1, V1, but you use your formula use your volume as V1 instead of effective 1, then you'll get the total mass in the cylinder. And the examiner sometimes ask you to then work out what is the mass that remains in the cylinder, which you can see at the bottom. If you take the total mass, which you get from V1, and your effective mass that you get from VE1 or VE2, doesn't matter. And if you subtract those two, you get your mass remaining. Is that okay?
Very well. Thanks, Mr.
Okay, thank you.
Hi, sorry to interrupt. Gaby, the mic is on mute.
Oh, we've been muted.
Okay. Can you hear, Zakeri, can you hear us now?
Yes, I can hear.
Yes,
Mr.
we
Dieter.
can.
Okay, okay. You said you've got a question?
I think it was that we were muted.
But it wasn't exactly a question. I just wanted to inform you that the mic was muted and we can't.
Ah, okay.
Yes.
Thanks. Thanks very much. Where did you lose me? Can I go back?
Not necessarily. I was following and reading as well here because I think everything is explained.
Okay.
Perfect.
Okay, thank you very much. Yes, basically what we said is the syllabus specifically says that the Rankine cycle diagram must be able to the students, must be able to draw that cycle or diagram. They must also be able to do the TS diagram. So both those, the cycle and the actual TS diagram is explained fully in the textbook, moving from point 1 to point 2, point 3, point 4. So that's done in detail. I haven't really done the extract out of the textbook, but that's basically where it starts with those two cycles, the cycle and the actual cycle diagram. So that's want to go just check in. So I'm going to go to the next. There it is.
There we go.
Okay, another thing that I personally feel very strong about that is really important for the students is the actual flow diagram of the steam plant showing the airflow line and the flue gas line from the fuel through all the different components through the chimney, and also the water changing from water to steam. So explaining to them what is H1, H2, H3, and H4 according to the textbook. They're all different enthalpies, H1 and H2 being your fluid enthalpies. When it's still a liquid, H3 your enthalpy when it is a wet steam before it enters the superheater, and then H4 once it exits the superheater, which is will then be your superheated values. And then if you look at the air flow rate going at the entrance of the air preheater and exit of the air preheater, and then also the flue gas. As the flue gas is released from the fuel with a very high temperature, it flows over all these components that gives off heat or supplies heat to these components. Now, the reason why I do that as an actual flow diagram is that the students can understand if they look at any of those 5, or let's say 4 components, the evaporator, the superheater, the economizer, the preheater. There are 2 ways of determining the flow, the heat absorbed or rejected. So if they use the steam part, or the H values, H1, 2, 3, or 4, and they work out the change in the H's, that will give them how much heat is absorbed by the system. And if they work with the flue gases and they work with the flue gas temperatures, they can get the heat supplied by the fuel or by the flue gas to the economizer. So they must be able to work out Q, heat flow, both ways. Expects, or the syllabus expects, that they must be able to do using the gas flow line and also be using the enthalpy line. And the same for the preheater. So I try to give that diagram in the book, so that's really important or clear for the students to see which temperatures are where. So when the data is given, they can actually draw themselves a quick little diagram and fill in all the relevant temperatures and enthalpies, and then it's easy to see which ones are missing and which ones need to be still calculated. Okay, then the part that is sort of, I'll spend a little bit more time here, is the actual nuclear section. Here the syllabus states that they must be able to draw a layout of a nuclear plant. I expect it will be most probably be something where the layout is given to them and they may just supply the labels. So I'm not sure how the examiner is going to interpret that. But this is a completely new section. So obviously the left-hand part where the reactor vessel is, and the container building, and the control rods, and the steam generators, all that, the whole section there is explained in detail, each component and the function of each component and how it is manufactured. Everything is discussed in detail in the book. And if you look at the rest of the plant, is actually more like a normal steam plant where you have a turbine and a generator and a turbine and cooling water system. But this is done quite in detail because it is part of the syllabus that is completely new. Students will be required in the actual nuclear plant. They must be able to assess environmental impacts, which will just be personal feelings or things. Do you think it's good or it's not good, and so on. Obviously, a lot of discrepancy about that. Identify major housing parts and the components. That's all done in detail. Identify reactor systems, safety systems, determine chemical symbols. Now, that wasn't very clear in the syllabus, but it is basically just to know that uranium-235 is the main fuel that is used in the plants. They must be able to calculate the molecular mass and mass of an atom. And all of that is done in detail. We work with Avogadro's number and all that type of stuff. So that there are examples on all of that. So it's not something that, like Abel said, sometimes when we get something changed, that we sort of panic and think, what are we going to do? It's really done sort of in a clear way in the textbook. And starting with very simple things like working out the number of atoms and working out the mass of an atom, which is then later have to be used to work out the energy supplied in a nuclear plant. Okay, also as part of the new content is they must analyze a typical reactor operation, discuss things like the fuel assemblies, years of operation, the refueling and replacement of the fuel, and then perform typical thermal reactor calculations using appropriate formulas. It's like reaction rate, calculate the reaction rate, which is just the amount of fissions that takes place, the rate of fuel consumption in the reactor, and the working principle of the Rankine cycle, which is actually then already done at the start of the module. And then they also want to explain graphically representing the compression, expansion, heat supply, and the reduction process. That's on the TS diagram, on the pH diagram. That's done with the inclusion of the Rankine cycle. Here's some important formulas that is explained in the book. Unfortunately, there are some electrical stuff involved where we talk about things like electron volts. So a lot of this stuff will be completely new to the students. What is an electron volt? Let's explain the actual value, which obviously, excuse me, in exam situation, those values is physically standard constant values that must be given to the students. They need to basically be able to work out things like recovery energy or recoverable energy, power. There's a formula for power that is used in a textbook. Energy, basic formula is my energy over time. but then there's Newton's famous formula as well, mc squared, where c is the speed of light. That's also explained in the textbook. Then to work out the fission rate, or what they call the reaction rate, is a formula for that, which has to do with either the power developed or the heat flow in the plant. So it's not very difficult formulas. There's not a lot of variables really. It's all to do with what is given and what needs to be calculated. And obviously, I'm sure the syllabus will be, formula sheet needs to be upgraded to include these formulas. Okay, that was a new section. I don't know if there's anything there that is maybe unclear. If there is maybe any question that I can give a minute or so.
So far.
Okay, looks like it's okay. I'm going to carry on. You're always welcome to still chip in if you want. Okay, the modular condensers also completely nothing changes, absolutely exactly the same. I've just included, there are more diagrams, all the different types of condensers that you got in flame condensers, and internal and external flame condensers, and so on. All of that is there. I just included this one for today's presentation that say that we need to see, basically the student needs to know how does the exhaust steam flow takes place over the pipelines or the water pipelines, the direction of the water flow in and out, the direction of the condensate. And the reason why you need all those temperatures is when they do the mean temperature difference, and where they have to work out the area of the pipes of the condenser, and the number of pipes in the condenser, and the length of the pipes in the condenser. So that is just a diagram to explain all the relative temperatures of the water and the steam and so on. So that's the reason only why I included it in for today's presentation. Another thing that is also specified specifically in the syllabus is talking about, other than the rotary pumps, they talk about the Edwards air pump, that they must be able to sketch the diagram. So again, I'm sure the examiner will give the diagram, and they must write down the relevant labels, I think. So it's not something that's unfamiliar. It was also in the previous modules of power machines or syllabus. Okay, before we go on to module 5, we all okay with the condensers? No questions?
Got one question.
Okay, we've got a question.
I'm just going to unmute them quickly. Oh, that question disappeared.
Was there a hand up? Is it okay now? Okay.
Yes,
Okay.
but you can proceed. I pressed by mistake.
Oh, okay. Okay, thank you. Right, the module on module 5 on gas turbines and governors, that is sort of combined now. Partly gas turbines, partly governors. So the first section is spent on governors, and it specifically states that while it is new, the outcomes will be the students must be determined centrifugal force, sensitivity, and speed limits, which wasn't really specified in the previous syllabus, and also with or without friction. So ignoring friction on the sleeve, or including friction on the sleeve, and specifically just watt and a Porter governor. So the Hartnell governor is now excluded, where in the previous syllabus it was still in. Then Each and every example has got a diagram to show the relevant heights, radius, on the radii, the lengths, the angles, using obviously trigonometry to solve these triangles. But it's basically a diagram that shows the centrifugal force and the weight of the, what they call the fly balls, and the weight of the sleeve. When we look at the Porter governor. So every example will have a diagram like that to make it maybe easier for the student to grasp which triangle to work with and which dimensions he needs to calculate in order to get the maximum speed of the governor, rotating speed of the governor, and the weight of the sleeve, etc., etc. So it's just done, like I say, it's nothing new. It's just maybe done in a bit more detail. Here's an example. On example 5.7 in a textbook concerning a Porter governor, where the one drawing is when it is rotating at minimum speed, and the other drawing is when it is rotating at maximum speed. So it's got different radii, and different angles. Like I say, it's really explained step by step, triangle by triangle, how to solve all the unknowns. So it's just a bit more a step up of the previous explanations, I think, than anything else. We okay with that section of the work, module 5? Everybody okay? Thank you. I can carry on with
We've got one question.
So we've got one question.
Snowden.
Thanks, Mr. Dutoit.
Yes.
My concern, the gas turbine and governor, I can check the weight distribution here. It is 20%.
The what? Yeah, the weight of the module. Yeah.
Yes. Now, the gas turbine. Maybe I did not get you correctly there. Are we referring to the gas turbine that I discussed at N6 level?
Gas turbines
At N6 level.
At N6 level or
Yes.
N3 level? Yeah.
Then
Yeah, the N6, I see the N6 also has gas turbines, so that will be, yeah. We did put a bit of a comment on that when the syllabus came out, but it looks like it's going to be very, very much similar to N6, yes.
okay.
You see now when I go down to the gas turbines, it's exactly the same diagrams. They must be able to do an impulse turbine and a reaction turbine. So that will be, it will actually be, we actually said it's a repeat because it's also done in fluid mechanics. It's just that it's water instead of gas, but in any case, yes, it's definitely a repeat by the looks of it.
Okay. Then if the two are combined now, then I'm not sure if the question is relevant at this platform, because I was a little bit curious to see how much percentage will be allocated on the gas turbine and how much percentage will be allocated on the governors.
Yeah, on the governors, yeah. I personally think that they don't specify how much on each one. They just specify 20 for the whole module. But I expect it should be, that's just my guess, that it should be about like a 8-12 or even a 6-14 type of split, that the governors not really that relevant, that you can have like a 20-mark question on the governors. It will be more on it. If you look at the velocity diagrams, the diagram itself should count about at least about 10 marks or 8 marks. And then you still need to do some calculations on that as well.
Yes.
Yeah. Now, and it used to be two separate, it's now combined. But unfortunately, they don't specify. So I'm sure the examiner will be free to say that he wants to ask a big question on a governor and a very little simple question on a turbine, it's most probably possible that he can do that. So I'm not really sure what to answer there, to be honest.
Okay, thanks for now, Mr.
Okay, thank you.
One more question.
Yes, there's one more question.
Okay.
There we go.
Okay, thank you. Yes, I also just want to add more on the question he asked, because my understanding is in the old syllabus, gas turbines used to be like 15 to 20%. So now will it be like a 10-10 with the governors, or 15-5? Like,
Yes,
how much exactly will the split be?
yes. We specifically addressed that problem, and we didn't really get a official answer on that. Like I said, I'm not sure. I can't see that your velocity diagrams, I can't see counting less than at minimum 14, because there's quite a lot of work on that. So if he does ask both, then he will most probably have to do like a 8-12 or 14-6 split, I think. Unless he specifically says he's going to ask a full 20-mark question just on a velocity diagram. That's possible.
Okay, thank you.
I think my case is as good as whatever any of you people think. But definitely the turbine should count much more than the governor. It's definitely not a 50-50 split.
Okay, thank you.
Yeah, thank you. Basically, what I've done here on this turbine section is I first show the students the two separate diagrams, each one individually first, the inlet diagram and the outlet diagram, with the relevant angles and so on. I tried to make these diagrams much more simple, where the previous ones had a alpha and a beta and a gamma and a, like 10 or 8. They had like 8 different symbols for 8 different angles, where I just found that the students rather relate to 1 or 2 symbols, being alpha being your gas angles, or you want to call it a nozzle angle or gas angle, but all your alphas are gas angles, and all your betas are vane angles. Makes just a bit more sense. And then there's a subscript 1 and a subscript 2, for 1 for the inlet diagram and 2 for the outlet diagram. It just simplifies the whole setup. But obviously we combine the two because the AEB distance, your vane velocity, is common for both. So the actual diagram looks like this. But the students still need to understand that if you look at the ABC diagram, that's your inlet diagram, and the ABD diagram is your exit diagram. And it's actually like 2 separate diagrams. It's just combined on a common vane velocity. And then the angles makes more sense. We have a alpha 1 and an alpha 2, where your absolute velocities are drawn from, point A. And you've got a beta 1 and a beta 2, where your relative velocities are drawn from, and that's your vane angles. So I think, I hope it's going to make it a bit clearer to the students. And then another thing that I tried to show as well is your horizontal distance between D and C is what they call a change in whirl. Change in whirl velocities, which determines your power developed by the turbine. And the vertical distance between D and C, which is at point DE, that determines your thrust or end thrust on the shaft of the turbine. So I think the whole diagram just makes a bit more sense than what it maybe was previously shown. So that just all depends if you want to agree with it. It doesn't matter. Is there any questions on that diagram? Like I said, the diagram itself should be at least 8 marks minimum. And then the student still needs to measure certain lengths, certain angles, So I can't see that counting less than about 12 or 14 marks. Okay, everybody okay with that? Let's go on to the last module. Here we can slow down a bit if you want. Renewable energy systems. I've spoken to some people and they sort of a bit scared of this section. It's not really a lot of theory involved here as well. Calculations are a very small amount of calculations. There's only like 2-3 variables again that need to be calculated. So it's not a difficult section, but it's a new section, and it counts 10%. If I'm correct on the weighting system. And this new module introduces renewable energy systems and focuses on environmental impact, particularly your solar voltaic systems or your PV systems, the parameters of a standalone connected PV system. So standalone is like a lot of you people will have that type of thing when you do to counteract load shedding and so on. We have a inverter and that type of stuff with a couple of set of batteries and stuff like that. That's a standalone system, and the grid connected PV system is where you actually have a big system at home and you actually other than using the power yourself or electricity yourself, you also supply some power into the grid, which you get theoretically can be paid for now. So we need to discuss solar voltaic cells and solar thermal electricity generation. So a lot of the stuff will be, obviously, all the stuff is completely new to lecturers and students. Students are required to do the following, and it's quite a lot of the stuff. A lot of that is theory. It says the parameters of consumer scale standalone and grid-connected PV systems for identified site locations, know the operation of all these different solar power systems, identify the components of a solar PV system, explain the working principle of a solar system, draw a layout of a simplified solar power plant. And again, you can see there's Rankine cycle in that as well, because it's still a steam plant. So it's just that heat supply comes from something else and not nuclear and not coal-fired. Perform calculations using appropriate formula according to power injection into the grid and power and energy generated by solar thermal generation. So there are a couple of new symbols, there's a couple of new formulas, but it is really not a difficult section. It is not very involved. Formula, as you can see on the next slide, or the next one I'll show you now. Here's some sketches that I took out of the book to show the difference between a simplified standalone PV system, where you've got your solar panel supplying an inverter at the end of the day, and the rest of the power is stored in batteries for later use. And if you look at the simplified grid-connected PV system, it also has an inverter, but it's got to go through the distribution board. And part of it goes to your home for AC loads, your own AC loads at home, and some of that goes into the electrical grid, where we can get compensated for. Okay. It specifies that the students might be able to show a layout or be able to recognize a layout of a simplified solar power system working on the Rankine cycle. So if you look at that power block on the right hand side, that is still the Rankine cycle, still the same thing. There's a turbine, there's a condenser, there's a pump, and there's a steam generator, boiler, whatever you want to call it. It's only the left hand side that's different, where all the different types of power systems is explained in detail in the textbook. I've just done one with the heliostats, but there are obviously a lot of other different ways that we can collect sunlight and concentrate it and use that energy to send to the hot salt tanks and the cold salt tanks. Those are just storing systems for all the energy and the heat to be used later on. And from there, it goes through the normal steam plant Rankine cycle like all the previous systems. Okay, then there's some new energy systems terminology like collector efficiency. What is that? What is operating time? What is the performance ratio? So these are all small little calculations that is done in the textbook and explained in detail. Section 6.2.5 focuses on the calculations and formulas required for this new renewable energies. Things that is important there, collector area, which is the surface area of the solar thermal collectors in square meters. Solar irradiance, that is your amount of solar power that you received per square meter from, depends where you are on the globe itself. Where are you in South Africa and what angle are you in? And what angles are your solar panels and so on. So a lot of new stuff, a lot of new terminology, but like I said again, like I said previously, not really very difficult. Just to summarize, here are the formulas that is required. A is your area, P is your power, obviously, A is your area, G is your radiance, your efficiency symbol is just your efficiency of the system. And the only difference between the two formulas, you can see solar thermal generation, your performance ratio is just excluded from the formula. The rest of the formulas, energy is power times time, is a general formula that everybody knows. And the performance ratio just has to do with how much electricity in AC is converted into DC. So it's also more like a type of an efficiency. It's just called performance ratio, but it's actually also just an efficiency of the actual plant. Okay, well, this is a new module. Every new content, the students will manage if they know to use and substitute the given values using the formulas and equivalent provided. Again, obviously, those formulas will have to be on the formula sheet in order for them to perform these calculations. Okay, anything on that section? I know that is quite a completely new section. Is there any questions on that? Okay, good luck with this section. Like I say, it is new. Looks like there might be a question. Anyone?
Yes, Mr. or Ms. Mabuza.
So Mabuza? Sorry, we're just gonna unmute you.
Should be unmuted.
You looks like you're unmuted. Are you? Can you talk?
Okay.
Sorry.
Okay. Yes.
Yes. Thank you.
Am I audible?
Yes, you are.
Yeah. Just a quick one. Do you on your personal capacity, do you think lecturers need to be trained on renewables before they teach students, like to have broader knowledge, or lecturers can just read what is on the textbook and then just go to class? Or do you think lecturers need to be yeah?
To be honest, it's not really such a really difficult section. But you see, the problem is some lecturers are new in the field already, and then they have a new module to deal with. So yes, the ideal will obviously be that you can have like a type of a seminar, or somebody can get to your college and have like a workshop for a day just on that specific section, and maybe combine that with a bit of nuclear, just because it is a new formula, new concepts. Yes, but that is obviously going to depend on the aim of your college itself, and are they prepared to get somebody to come to you and explain, the necessary stuff. I think Gabby is going to talk to people afterwards about giving us feedback and stuff, and we can also see on your feedback if there's really a big demand for that. I'm sure we will be able to make a plan maybe through future managers that I can maybe represent something or present something to you as an example, instead of physically going from college to college. I don't know if that answers your question.
Yes, yes, it did. And then I don't know, maybe if I can have just a follow-up, just to so that
Yes, I
there's
think when
not-
it gets to the comment sections, we're also going to send you like a survey where you must comment on the actual what we did today and what was presented today. And I'm sure if you put something in there to say that you really have a need to have a bit of training in that section, then we can maybe at least follow that up.
Okay. Yes, I've got a follow-up question, sorry.
Yes.
Yeah, like this, I don't know, maybe we've mentioned before, because at the beginning I didn't hear anything. There was no audio on my side. I want to know, this new syllabus, must we start to teach it the next trimester? Just, I don't know, what's your knowledge about that?
Yes, the new syllabus comes into effect as from September 2024. So the first exam will be on at end of the year, the November, December exams. They
Okay.
will write on the new modules, yes.
Okay, thanks a lot.
No, I don't have the exact timeline, but I could ask Gabby. The textbooks should be available not very far in the future now. And then, so there's enough time that you can get all of the textbook, and obviously there will be some, what do you call those books that they give out?
Sample copies, yes.
Yeah, sample copies. There will be sample copies spread to all the colleges.
Yeah, the sample
So,
already, yeah, we've got
yes.
the sample on my side, yeah.
You've got now,
Yeah.
there will be a change in the sample copies because we made some changes and we put some extra examples in, some extra drawings, some extra exercises. So it's a little bit different to maybe the one that if you have received one already, it will be a bit different, yeah.
Okay, thank you.
Okay, thank you. Another question?
Another question from Zakele.
Zakele, you may just unmute you. You okay? Zakele, you can talk?
Yes. Thank you, Mr. Dutoit. I just have a question based on this chapter that we're talking about, which is the module 6 of the renewable energy. I see there's a lot of content based on the theoretical part, and because I also have the promotional copy here. It's only 2 questions that have got the calculation. So I would like to know, like, for exam purposes, how is it structured? Is it more on the theory or more on the calculations?
Yes, that I cannot really answer. I'm not involved with examinations anymore. But like you see, it's going to be difficult because it is only supposed to be 10 marks. And if I look at the calculations, if they're not going to ask you the power generated and they're going to ask you the performance ratio as an example, that should be at least 4 or 5 marks on the calculation. So it can most probably be split 5-5 if I must form an idea.
Okay.
I don't think it will be a full 10-mark question just on calculations. There's quite a lot of theory as well. Yeah, like the examples, the advantages and disadvantages, and the difference between a PV system and what does PV stand for? What is photovoltaic? All those type of things I'm sure will come in the beginning because it's a new section. Yeah.
Okay. Thank you.
Okay. There's one more question. She just
Snowden.
Yes, Mr. Dutoit.
Morning. Afternoon.
Yeah. Mine was, I'm sure the previous colleague has they have mentioned it already. The exam November examination.
Yes.
I'm not sure the question that future manager has got from the curriculum reviewer from the Department of Higher Education, because we believe new changes will be on the paper for November examinations.
You're talking about N5 now?
The N5.
The N5 is definitely implemented from September onwards. The third trimester, and you'll be examined at the end of that trimester, and then N6 is then supposed to come in on January next year.
Okay, no, mine was still on the last exam of this year, so we can teach this new section without a fear that we know this question paper are set on I'm not sure is a 2-year cycle or how many year cycle. Maybe we will be teaching something that will not be on the paper.
No, your normal examiner sets up a set of exam papers for 2 years, yes. But with the new syllabus coming in, they would have already, because I know there's an exam coming in, that they will want the rest of the remaining questions, whatever is left of the question papers that are still left in the department's possession, that will be moderated and changed according to whatever the syllabus is. So it will definitely become, it will definitely be in. Nuclear plants will definitely be in, and renewable energy will definitely be in, yes.
Oh, thank you for that.
Okay.
The second part of my question was the textbook that you someone mentioned it. Is the N6 textbook already available?
Now, the N6 textbook will be available most probably here by November, I would say end of October, November. Most of the stuff is finished already, but obviously it must be typeset, and we must still send it to the department to okay it. So it's not available at the moment now.
Okay, fair enough. Thank you for now, Mr. Stone.
But I think also, if I'm trying to think quickly on Power Machine 6, what changes this renewable energy of the solar system gets sort of renewed into wind turbines. So I think that's the only thing that's really new on the N6 as well. The rest of this stuff must stay the same as the previous one. And we've got one. Yes.
It's Muslim Kabiti.
Kabiti.
Oh, for the new one, this other meeting.
Okay, my question is on, I see you recording the meeting.
Yes.
Are you gonna make the recording available to us?
Yes, absolutely.
And then
all the people that are registered will get a copy, and even the people who could not attend it, that maybe had some problem that they couldn't get on or whatever. So everybody that has registered will get a link to access the actual recording. Yes.
okay, thank you for that.
Did you want to know that if your voice is on the system or not?
No.
So you can hear yourself.
No. The second question is, I heard you say those sample books that was made available, you've already made some changes on them. So
Yes.
Are you gonna avail the one with changes again?
We don't really do another sample.
I don't think we really do another sample. The basic stuff is all there. The only thing that we've done is maybe with 1 or 2 examples, because remember when we send the thing in to get accredited, then what they call the screeners, they make some comments and they will say, can you maybe put an extra example here? Can you maybe put an extra sketch here, whatever? So that's all we've done. So the basics are there. It's just when you get the actual textbook, where there maybe were only 3 examples on renewable energy, there will now be 6 and stuff like that. So especially on the renewable energy and on the nuclear plant, we did a bit more stuff in detail. So there's nothing wrong with what you've got in the sample copy. It will just be a little bit more detail.
Oh, okay. Okay, no, thank you so much.
Okay, pleasure. Okay, then if everybody is happy, I'm going to sort of hand over to Gabby again, so you can just talk about all other general stuff that she wants to talk to you about, and specifically the survey and the feedback. We will really appreciate if you give us a feedback, positive or negative, doesn't matter. We also just start learning. So yeah, okay, but here's Gabby.
Hi there, everyone. Thank you very much for your engagement. I'm just going to take you through, if we just go back to tips on addressing challenges, from previous workshops, some classroom practice guidelines we discovered we're just listing a few of them here. Some of you have been doing this for very long, but sometimes it helps to go back to the basics. So just a few things to remember is that you'll find all the answers to calculation questions at the back of the student book. So if students are working through the exercises, they can always go check their work and check that they are on the right track and getting the right answers. Similarly, with the examples that they do in the textbook, the solutions are provided. So just encourage them to work through that and to make sure that they understand what they're doing and to ask you to explain if they are struggling there. We know that there's sometimes, very complicated terminology and sometimes language barriers and things like that. And not everyone's got this background of engineering or can understand how to make the connection with industry, which we know is very important in TVET and with these trades. So just remember to make that connection with them and encourage them to work together and help one another. But I'll let you'll have a chance to read through these different tips. Sorry, if you don't mind muting your microphone. I think I'm just getting some feedback.
Keep my personal, my personal stuff. I can give it to you. Email and
Piet has also mentioned that if you have any queries, you're more than welcome to reach out to him if you're struggling with a certain concept and would like to just have a bit more background. And so if you'd like his email address, we'd be happy to put you in touch with him. I think there'll be some more time for more questions now. I think if everyone's satisfied, I'm going to just go through some more information about the books. Let's check. Mr. Zakele, I see you've got a question. You may go ahead.
Right, thank you, ma'am. It's not actually a question, it's just a comment maybe that on something that needs to be looked at. I've gone through the exemplar textbook here. What I've discovered in most of the most of the modules that we are having there is less activities for the students to do the practice. So you find that each activity has got only 2 problems or 3 problems, which makes it difficult for them to broaden their knowledge, because remember, students need to practice using the questions that maybe have been asked. So all I would like to say here is that if maybe it's possible, can they increase the number of problems that are there for the activities, so that the students, when they practice, they've got enough questions to widen their mind.
I hear you. Thank you for that. We've definitely added some more examples and exercise questions, something that will also come in which I'll touch on, is that we will be drafting our own sort of exemplar examination paper, because obviously there are past papers that you've got access to, but we know it's not based on this specific syllabus, even though there are similar topics, and that not much has changed. So we will be including that as well. So hopefully that will help a bit, but thank you for that. And then I've got another question. Mr. Nodum, you may go ahead.
Yes, thank you. I'm not sure if the copy I have here, it is the final copy, or I don't know what to say.
It's
Yeah.
a sample copy, so yeah. But it's not the final, no.
Yeah, it's not written sample copy, it's written promotional copy. I'm not sure what the difference between the two. But the different exercise do not have answers. Not at the end of the book, not included next to the question.
Oh, I see. Yes, yes. Thank you for that. Yes, we've included that now so that they'll have access to all of that at the back of the book. It will be just before the glossary in what's your sample copy. So those will be the final answers, but then obviously explained the fully worked out calculations in the lecture guide. Yeah, but the final answers for the students will be included in the final version. Yeah, but it's not in the sample copy. You're correct.
Oh, thank you for that. So are those final products already available?
They will be available very soon. I've got a few, there are some other things we're adding. We got some feedback from one of the colleges also. They've asked us to include STEAM tables, just to make it easier for students when it comes to the exam, so that they're familiar with those formula and those values.
Yeah, because I put my request already from my college to get access for some copy for next trimester. I'm not sure how practical will that be.
They will be available very soon, but what I'll do is we'll make sure that our customer services team is able to give you those turnaround times so that you get your books in time. Yeah, they'll definitely be available like ahead of next trimester, and you'll have them all on time. Yeah.
Okay, thank you.
Thank you so much. There's another question. First is Sipiwe Butelezi. You may need to unmute yourself, but you're welcome to go ahead. Sipiwe, do you have a question still? Okay. There is a question or a hand up from Dlamini. Ms. Dlamini, you may go ahead.
Yes, ma'am. This is Sipiwe. We were late I was late in the meeting, so I'm just wondering if you do keep the records for the meetings.
Yes, sir.
Recordings meant to say.
Yes. We've recorded this session, but what we'll also do is we'll make this presentation available also so that you can flip through and share with your colleagues also. If they never got a chance to attend or anyone new joins, you'll have access to it, yeah.
Okay, how can I get it from the link or where?
I'm going to explain some of the ways that we'll make it available, but I can email it to you. If you must just remember your name, Mr. Butelezi. Yeah, I should have your email address, so I can email it.
Yeah, email it to Mrs. Butelezi, yes.
No problem. Okay, I'll make a note of that.
Sorry. Okay, sorry, ma'am. The new syllabus that we are talking about here, doesn't involve, is it more, because the other syllabus, it's chemistry and STEAM. The other one, do you have anything like more mechanical in the new syllabus? Because power machine is a mechanical subject.
Piet, I think I'm going to hand you over back to the author, back to Piet. Did you get that?
What's it?
It was asking about all the new syllabus. Does the new syllabus include more on steel and
Sorry, just repeat your question, what you asked there, sorry, man.
I just want to check here in the new syllabus. I saw the renewable energy. Renewable energy, I understand what you are talking about, but I'm electrical. I'm teaching in electrical. I'm a lecturer, so I know that power machine it's a mechanical subject. So in a new syllabus, what you have added is more electrical or more mechanical.
Yeah, it's still completely mechanical, but obviously when we go onto the solar part of it, the solar part is actually much more electrical than mechanical. So we've just limited on the actual power supply per square meter of solar panels. So that's about it. We talk a little bit about the electron volts, what the charge is for that, but that's about it. Other than that, we can't really go into detail on the electrical side. So it's all still purely mechanical, yes.
Yeah, it's just that as an electrical lecturer, I always come across with questions in student because even in electrical, we're doing power machines. So, for an example, the chapter, the governors, you know the governor, the last chapter in the book.
Yes.
So I've noticed something. You brought back the questions from the governors. But when I look at the governors are more like mechanical, you know, it's easy for mechanical student to understand them rather than the electrical student. So,
yes.
So I just know you know, in terms of setting the paper, you know.
Yeah, you see, what also actually happened is that we actually tried to get governors out of the syllabus because it's not really mechanical anymore all these days. It's all electronically done. So, but unfortunately, this is what we got, and you know, we must work with this.
Okay, no problem. Thank you, sir.
Okay, thank you. I agree with you.
Yeah, thank you.
Okay, thank you.
Yeah, two more people. Mr. and Ms. Dlamini, would you like to go now? Hi there, you may go ahead. Okay, I think Dlamini has dropped off. Lechodi, you may go ahead with your question.
Good afternoon, everyone.
Afternoon.
I'm sorry, I just got the reminder now. I was just going to second, like, can we get the record so that when whatever that we miss, so that we can get back to you? Something
I'll answer that, Mr. Lechodi. Yes, you definitely will have access to that recording, and I'll also share this presentation so that you can have access to the slides.
Okay, thank you very much. So that when we have the question to get the book, so that we can know what we saw, because now I cannot
after that with the
ask the question.
No, definitely, it will be made available.
Thank you.
Thank you. Are there any other questions? Well, we're all good for now. If you do think of anything, you're more than welcome to let someone know and they'll answer. If that is all, then I'll just I just want to thank you again for your engagement. Some very good questions, very valid questions. So thanks for grappling with this with us. I just wanted to remind you that we have dedicated subject microsites, which are individual web pages for the students and for the lecturers. And so these will be accessible via links or QR codes at the back of your book, hope the screen is showing it now, but it's this QR code. So if you scan that with your phone, you might need an app to be able to scan the QR code. If you scan it with your phone or you type in that short link, it will take you to a page on our website, and that will have past exam papers. We'll put our exemplar examination paper there. We'll put PowerPoint slides there. For the lecturers, we'll have a separate site, which you also can scan from the QR code. So that's a specific one for the lecturers. This will have additional resources like these PowerPoints, these specific ones for going through the syllabus, as well as the lecturer guide as a PDF, which you can use. And then, as we've touched on, we've just added some extra things to the sample copies you would have received. So we've also added the STEAM tables to the back of the book. And we thought it would just be helpful for students to be able to access this, to be more familiar with the formula and the values that they might need to use in the exams. We've included many examples in the book, and I've added some more. So we hope that you and your students will find it easy and will enjoy working through them and working through the summative assessments. We've got links to relevant resources or extra videos or demonstrations where you might not have time to go through it in class, but you might want to reference it to show your students, or in their own time they can click on these links, and we've tried to keep them short so that it doesn't use a lot of data. Just extra explanations that might help them with the theory or understanding concepts for how everything works in your technical subjects. We've also included definitions throughout the book. There are lots of important concepts and terminology, so we've just tried to make sure that these technical terms do land with the student and that they do understand it, because that helps a lot when you're learning a subject. And then again, yeah, if you have any questions or if there's anything that you'd like to know, please feel free to reach out to our CARs, the key account representatives. I'm sure you know them way better than you know us. That's Clint and Sinatemba and Innocent and Faith. Please feel free to reach out to them. We'll also be circulating a very short survey just to get some feedback from you, find out what was useful, perhaps what wasn't. Like Piet said, we're open to all feedback, and we'd like to be able to do more of this going forward. So we'd like to know how we can help you. Future Managers is really big on lecturer support and making sure that you feel confident and you feel equipped. So I hope there are some things that you've learned today. And thank you so much. We wish you every success with your teaching. If everyone's happy, if there are no other questions, then I'll end the call.
Gabby, I see there's 2 questions here, or 2 hands raised. Just check.
Thank you, Clint. First, we've got Mr. Lechodi again. You may go ahead, sir.
I just want to find out, because the author of the previous book from the Future Managers is Mr. or V. Hagner, isn't it?
Yes, yes.
For power. The previous theme table, it was wrong on the superrated part.
Okay.
It's not the one that we use on the examination. It's just there was something that was wrong with that one.
Thank you for that. Piet is nodding his head there. He agrees with you. Piet was after the fact assisted us, because I believe that author passed away. Eh? Yeah, I think he had passed away. So when we needed to do updates, Piet took a look at that. So that's why he's taken over this subject. But we will be that should be addressed now. Okay. Yeah, we using the actual exam now.
The one that
Yeah,
you
that's
get
what I wanted to highlight.
Yeah, that yellow book that you get in the exam, we've used that exactly as it is in the table, so it should be a bit better. And we obviously are making sure that there are not any mistyped numbers or so. So it should be hopefully 100% correct by the time you receive it in the textbook.
Okay, thank you very much.
Thank you. And then there's another hand from Bafana Sinokwe.
Hello, everyone. I'm sorry I was very late. I've been struggling to join the meeting. I would like to see the cover of the book. Can you show me again?
I can go right to the back. I've got a copy here, but I think it will be clearer on screen. So I'm going to take you over here. So this is the one. I don't know if you've got a sample copy yet, but this is what it should look like.
No, I don't have it yet.
You don't have it. Okay.
Yes.
I'm going to make a note of your name. Maybe we can still get a copy to you. I'm sure we can.
Okay, thank you so much.
Which college is it?
Which college are you from, by the way?
Elangeni College.
Elangeni. And
Yes,
your
Ntozuma campus.
Okay, all right. Okay, now I'll follow up with you. One of my teammates will definitely get hold of you.
Okay.
We can find out. Maybe we just needed to get an extra copy because I think we would have gone to your campus if we had you on the database. Yeah.
Thank you so much.
Thank you. You're very welcome. Well, I think I don't see any new questions. Unless, is that another question from you, Mr. Lechodi? Or is that the old one? I think it's the old one.
That's the old one. Thank you.
No problem. All right, then thank you very much, everyone. Thanks for your questions and for your engagement, and we hope it all goes well with teaching this in the new trimester.
Thank you very much.
Okay, thank you. Just a last word from me. You are really, really welcome to contact me personally by email or cell phone if you really have a problem in the book or something that you're not sure of or need some assistance or need to clarify something. You're welcome to contact me. Get all of Gabby, and Gabby will get in contact with me if you want.
Okay, thank you. Can you please share your email address and that of Gabby so that in case we need to contact you?
Absolutely, yes. Absolutely.
How are you going to share it? You're going to share it on the chat? Or...
I will share it on the chat now. I'll share mine, and then even if you don't, or you can try info at Future Managers because they will definitely send it to me. So I'm sending my email address, and Peter, I've forgotten yours.
Peter Toy.
That's correct. Okay, then everyone will see that. But yeah, thank you very much, everyone. Hope you have a good day further and all the best.